Deliverables, work product. Test deliverables which are given to the stakeholders of software project during the software development of life cycle. Some test deliverables are provided before testing phase, some are provided during the testing phase, and some after the testing cycle is over. There are different test deliverables at every phase of the software development life cycle that are requirements or design review phase, review defect reports, test planning phase, test plan, test estimation, test schedule. STLC phases mentioned above do not necessarily have to be in the order listed. Some phases can sometimes run in parallel. For instance, test designing and test execution. Test designing, test cases, test scripts, test data, requirements traceability matrix. Test environment setup, test environment. Test execution, test results, incremental. Test reporting, test results, final. Test defect matrix. Error control in the software environments. The following figure shows how there is a cyclical relationship between error control in the live and development environments. Interworking and integrated problem management systems facilitate the handling of this situation. Error control. It covers the processes involved in successful correction of known errors. Error control activities. The objective is to change IT components to remove known errors affecting the IT infrastructure and thus to prevent any recurrence of incidents. Many IT departments are concerned with error control, and it spans both the live and development environments. It directly interfaces with and operates alongside change management processes. The following figure shows the three phases of the error control process. The monitoring and tracking phase covers the entire error life cycle. Error identification and recording. An error is identified when a fault is detected. A known error status is assigned when the root cause of a problem is found and a workaround has been identified. There are two sources of known error data that feed the error control system. 1. Problem control subsystem in the live environment. 2. Problem control subsystem in the development environment. Errors found during live operations are identified and recorded in problem control activity, investigation and diagnosis. The problem record forms the basis of the known error record. The second source of known errors arises from development activity. Implementation of a new package release has known but unresolved errors from the development phase. The data relating to known errors from development needs to be made available to the custodians of the live environment when a release package is implemented. Problem management system should provide a record of all resolution activity and provide monitoring and tracking facilities for support. Error assessment. Problem management staff perform an initial assessment of resolving the error. If necessary, then they complete an RFC according to change management procedures. The priority of the RFC is determined by the urgency and impact of the error on the business. The RFC identifier should be included in the known error record and vice versa in order to maintain a full audit trail, or the two records should be linked. The final stages of error resolution, impact analysis, detailed assessment of the resolution action to be carried out, amendment of the item in error, and testing of the change are under the control of change management. Errors in third-party products. Problems in vendor-maintained products may be identified by problem management teams and should be reported to the person responsible for vendor support. Vendor support should be monitored to ensure that responses to problem reports are received in a reasonable time. Software maintenance targets are specified in a contract or in license conditions. Remedial action should be initiated with the third-party organization. The possibility of specifying maintenance targets should be borne in mind when procuring software, particularly when there is a competition for the business. Note that changes necessary to resolve software errors should be subject to the same change management procedures as for internal products. Error cycle in the software environment. Processes of problem and error control are essentially the same in the live and development environments. The following figure shows how there is a cyclical relationship between error control in the live and development environments. Errors found during live operations result in an accumulation of RFCs, requests for change. Development staff should be aware of all known errors and problems that are associated with a package release. They are required to delete known errors as they are corrected, but they add any newly introduced errors from the development activity itself to a revised error database. Upon implementation of a new release, this revised error database replaces the database of the previous release as a live version. The cycle then repeats itself as new errors are discovered in live operation. Error resolution recording. The resolution process for each known error should be recorded in the problem management system. It is vital that data relating to all known errors is held in the known error database. This data is available for incident matching, providing guidance during future investigations on resolving incidents and for providing management information. Error closure. Following successful implementation of changes to resolve errors, the relevant known error record is closed together with any associated incident or problem records. Known error and problem records are closed pending PIR to ensure that the fixes have actually worked. A post-implementation review, PIR, can then confirm the effectiveness of the solution prior to final closure. For more serious problems and known errors, a formal review may be required. Error resolution monitoring. Change management is responsible for processing RFCs, whereas error control is responsible for monitoring progress with regard to resolving known errors. Throughout the resolution process, problem management should obtain regular reports from change management on progress in resolving problems and errors. Problem management should monitor the continuing impact of problems and known errors on user services. Problem management should escalate the problem, perhaps referring to the change. Advisory board to increase the priority of the RFC or to implement an urgent change as appropriate. The progress of problem resolution should be monitored. Software Development Lifecycle (SDLC). It is a well-defined structured sequence of stages to develop a software. Please see the diagram shown. Requirement and analysis phase, design phase, development phase, testing phase, maintenance phase. Requirement and analysis phase. In requirement phase, the project requirements are gathered from customer by the business analyst. In analysis phase, features and functions of the project are determined. Documents prepared in this phase are User Requirement Specifications (URS) based on customer needs, System Requirement Specification (SRS) based on URS. Design phase. Two types of design documents are prepared here. High-level design defines the overall hierarchy of the function from root level to leaf level. Low-level design, internal logic of each module in the project are defined. Development phase. The code is produced by the developer. This is the longest phase of the software development lifecycle. Testing phase. After the code is developed, it is tested against the requirements to make sure that the product meets customer expectation. During this phase, unit testing, integration testing, system testing, acceptance testing are done. Maintenance phase. Implement new requirements after the software is deployed at the customer location. The maintenance phase includes handling the residual errors that may exist in the software even after the testing phase. Software Testing Lifecycle (STLC). Software testing lifecycle process is a part of the software development lifecycle. The overall aspect of STLC phase deals with testing and rectifying any error code generating within the program under various test conditions. Requirements Design Review. Review the software requirements or design. Test Planning. Preparing the test strategy and planning. Test designing. Design tests on the basis of detailed requirements, design of the software. Test environment setup. Set up the test environment, server, client, network, etc., with the goal of replicating the end user's environment. Test execution. Execute your test cases, scripts in the test environment. Test reporting. Prepare various reports for various stakeholders. Software development lifecycle versus software testing lifecycle. Please see the diagram shown. The table shows the clear differences between SDLC and STLC. Software testing is the process of finding bugs in the software and making the software bug-free. In SDLC, the testing plays an important role which helps to improve the quality, reliability, and performance of the software. It checks the software functions, what it is supposed to do, and what it is not supposed to do. Software testing is very important because this helps to find the defects and errors that were made during the development phases. It makes sure that the application meets the customer needs, to ensure the quality of the product, to gain the customer's hope, to provide the software application which requires lower maintenance cost, to provide more accurate, consistent, and reliable results of the product. It is required for an effective performance of software application, to ensure that the application should not result in any failures. Version control. It combines procedures and tools to manage different versions of configuration objects that are created during the software process. Configuration management allows a user to specify alternative configurations of the software system through the selection of appropriate versions. This is supported by associating attributes with each software version and then allowing a configuration to be specified by describing the set of desired attributes. Attributes mentioned can be as simple as a specific version number that is attached to each object or as complex as a string of Boolean variables, switches that indicate specific types of functional changes that have been applied to the system. One representation of the different version of the system is the evolution graph. Each node on the graph is an aggregate subject, that is, a complete version of the software. Each version of the software is a collection of SCIs, source code, documents, data. Each version may be composed of different variants. To construct the appropriate variant of a given version of a program, each entity can be assigned an attribute tuple, a list of features that will define whether the entity should be used when a particular variant of a software version is to be constructed. One or more attribute is assigned for each variant. For example, a color attribute could be used to define which entity should be included when color displays are to be supported. Another way to conceptualize the relationship between entities, variants, and versions, revisions, is to represent them as an object pool. The relationship between configuration objects and entities, variants, and versions can be represented in a three-dimensional space. An entity is composed of a collection of objects at the same revision level. A variant is a different collection of objects at the same revision level and therefore coexist in parallel with other variants. A new version is defined when major changes are made to one or more objects. In this chapter, we have covered the following in detail: software testing and its importance, software development lifecycle versus software testing lifecycle, deliverables, version and error control.